Hello everyone. Today we'll continue our discussion on finite state machines and we'll take little more sophisticated examples. Let's assume the problem we are taking is we would like to find two streams. If our number is matching 0 1 0, then we will return 1, or if it is matching 1 0 0 1, then we will return 1. The machine which we are going to design is a Mealy machine. That means that when the output would depend on the input, so when the input will change, the output will also change. So now how do we start? Like our previous question, the input is a single bit X and output is also a single bit Z. Now this input is being given as a serial input. This serial input, as soon as the sequence is 0 1 0, we should get Z as output as 0, output as 1, and if the previous inputs are 1 0 0 1, then the output should result in 1. Otherwise my output should be 0. So how should we start? First step to understand these problems or to solve these problems should be that we can take a example sequence so that we understand the cases what could arise whenever we are solving them. So let's try to write some sequence X. So let's say this is my X, 0 1 1 0 1 0 0 1 0 1 1 0. Now this should be my Z. You remember that first we have to find an initialization condition. Initialization condition, let's assume that the before the start of the sequence there was a 0 here. So keeping that in mind, now let us see if it was 0, then here we have just started, so it would result in 0. This would result in 0. This will also 0 0 1 1 does not match any of the sequence, so will be 0. Now 1 0 is again not matching anything, but yeah, it would result in 0. 1 0 1 again it should result in 0, but when the sequence is 0 1 0, then here my output should be 1. Now the next one, as soon as the next input is 0 1 0 0, it's still not matching anything, so the result is 0. 1 0 0 1, the result should be 1. Again 0 1 0, at this point output should again be 1 because it is matching this sequence. At this point 1 0 1, it's not matching anything, so the output is 0. Here also it is 0 and here also it is 0. So with this we have some understanding that how my sequence should behave like. Also let's understand that as we are going in this direction, time is increasing. So this particular 0 is available at time 0, this is available at time 1, this is available at time 2. At any point of time we are looking in the past that if the sequence is, so when we are saying that we have to match 0 1 0, so basically this should be t, this should be at t minus 1, this should be at t minus 2. Similarly, if we would like to match this at time t, then 1 should be there at t and 0 should be there at t minus 1, this 0 should be there at t minus 2, this is there at t minus 3. What is 1 here? 1 is the clock period. So because all of these state machines we are designing as a synchronous state machine, so when with the change of the clock period, with after one clock period the input is supposed to change, and then we are supposed to see the output. Okay, so how should we start? To start this, let's try to drive a state machine. So when we would like to drive, how should we start? We always it would be good to start with the initial state. Let's call this as S0. Okay, so S0 is just an initial state which also somehow represent this dotted line, which means that we don't know what has happened before that. So it could be a reset state, it could be an initial state, and there if something is so we always have to start with some state which is an empty or would be an initial state. Okay, now then what should be the next step? There are two sequences which we have to match. So what we can do is we can initially start with one of it, and then we can take on the second one. So let's take the first let's take first this particular string. Now remember we are going to design a Mealy machine. So S0 is my initial state. I'll write here what is my S0. S0 is my initial state. Now if there is a input is 0, let's say input is 0, then I should move to the next state. Why we are moving to the next state? Because we are we have to remember that there is 1 0 here. Okay, now what should be the output? Because there is only 1 0 which has matched, so the output is 0. Now after that, let's say the next input is 1. The input is 1, we should again move to the next state, S2. Why? Because this is unique, this is different than 0 and 1, so the output should again be 0. There is an arrow here. The transition represents that there is a 1 is the input and 0 is the output. S2 is a distinct state. So I can write here also S1 means that there we have found at least 0, and S2 says that 0 as well as 1 is there. So this is my interpretation of my states, which may also keep on varying as we are moving. So this interpretation will always help us to remember that what is the significance of any particular state. Now after that, if I receive another 0, so that means 0 1 0. So if I receive another 0, the question would be where should I move to? For now, let's keep another state. For now means that we may see that in future do we require that particular state or not, but we'll keep that state in our mind. So here let's have this as S3. S3 means that there is, if there is a 0 here, the output is going to be 1. Now what does this S3 mean? S3 could mean multiple things. It could mean 0 1 0, or it can also mean that it is 1 0. Yep. So here we are sure that the output is going to be this 1, because we have matched this particular sequence. What would happen now shall we, so there are two possible ways to move forward. One possibility is that we'll complete this state machine. Right now this state machine is incomplete because we have not seen for this S0 state what would be the transition if the input is 1. Similarly for the S1 state, what would be the transition if input is 0. So state machine completion is one task which is remaining. The other thing is we can start with the second sequence also. So let's take the second sequence first and then we'll complete the state machine. Now for the second sequence, we see if it is 1, if the input is 1, then we have to have, let's write as the S3 we have already written. So let's create another state S4, which means that input is 1 and output is going to be 0. So this S4 essentially means that there is only 1 which has been recognized. So this one is different than this one because this one says that there is a 0 preceding this, but this one means that there is no 0 preceding it. Okay. So let's go back to the next one. If it is 0, now the input is 0, the next input is 0. So one possibility is that we can say that if let's keep it in a dot and then we can finalize that. Let's say that this is the next state, 0 and then 0. Are we sure? To make whether we are sure or not, then we have to say whether S3 should represent 0 1 0 or should it represent only 1 0. Now to understand this, let us look at these input sequences in patterns which we want to like to match. Here what we would like to match is we would like to say what the patterns which we would like to match here is, let's write that in green. So we would like to match 0, we would like to match so this would be 1 if 1 0 1 0 is there. So that means S2 already represent that 0 1 is there, and S3, if S3 is coming from S2, that means that 0 1 0 is there. Okay. Now that's what we would like to remember. Now we would like to remember 0 0 1, yeah, and here we would like to, for this pattern we would like to remember 1, we would like to remember 1 0, we would like to remember 1 0 0. Okay, and at the time we are here at 1, this state, remembering this state is sufficient. Similarly, when we are at this point, remembering this state is sufficient. So this may not be required. The only things which we have to remember is this. Okay, so that means this S3, even if we say this 1 0, this is sufficient. So that means, that also means that from S4, if there is a 0 input, then we can say that the transition is towards S3. Then we are saying S3 means this only, and yeah, S4 is 1. Okay, so now we have let's come back to the sequence. If input is 1, from initial state, if input is 1, we have reached S4, and from there the next input is 0. From S4 we will go to, the transition would be towards S3. Now at S3, if there is an input which is 0, now we have to create another state because we would like to remember it is 1 0 0. So we create another state which is S4. S4 is already there, so we will create another state which is S5. Now the state is S5, and from S5, if it is 1, then we are clear that if it is 1, then we have to go to some state, but the output is going to be 1, that we are sure. But to which state we should go? let's write it here also. My S5 means that 100 is it remembers. Okay, so out of these, if it is 1, then what is the most useful thing? We are there at S5. So from S5 we would like to see that now the input is 1, so that means this 1 represents that the sequence is so far 1001. Now out of this 1001, what is the most useful thing here? We can say that it is actually 01, which would be helpful in identifying any other pattern, the pattern which we are matching. So that means the next state is supposed to be S2. So let's make that. So if this is my arrow, this was my arrow. So from S5, if input is 1, then output is 1, the next state is S2. Why S2? Because it represents that the last pattern is 01, actually this part. So that's why we will move this state to S2. So with this we have matched both the patterns. Now it is still a incomplete state machines. Let's try to complete the state machine. How do we complete the state machine? That at every state we should know that for all the input combination what should be the next state. So for S0 we know that if it is 0, then the state is S1. If S0 the input is 1, then we will go to S4 state. Similarly we have to find out for the other one. Now one more thing we have to understand, that this, whenever we are saying S0 S1 0, which means that it is 0 but it is not 01. Okay, so this and this states are distinguished. And similarly this is the, so we can rub this part. Yep. Similarly when we are saying 1 means it could be only single one, anything preceding that we don't know. Okay, so now let's again look at the S1 state. From the S1 state we know that if it is the input is 1, then we'll go to S2 state. But if the input is 0, what state we should go to? So if input is 0, then it will be we are talking about S1 state. If the input is 0, so that means the sequence we have received is 0 0. So out of this 0 0, we see that the only thing meaningful we can receive is, we can discard this part, we can say it is still 0. So we can mark it as it is back to S1 state. If it is 0, the output would be 0. Now let's look at S2 state. S2 state, we know that if input is 0, then it will go to S3 state. But what would happen if the input is 1? If input is 1, what does it mean? If input is 1, this means that we are talking about S2 state. At S2 state, if the input is 0, the sequence it will become is 0 1 0 1. Yeah, we are talking about 1. So 0 1 1. So out of this 0 1 1, what would be the meaningful state? We can look at this sequence, or we can look at this graph itself. So if it is 0 1 1, then we are this particular any of the pattern has not matched for this particular pattern. Any bit has not matched for this pattern, and for this pattern only the first bit has matched. So that means it may be a starting of the next sequence. So we have to say if S2, at S2 the input is 1, then we are going to S4 state. Okay, now let's look at the S3 state. At S3 state, we know if input is 0, then we are going to S5 state. But what if input is 1? So at S3 state, we are talking about S3 state, and S3 state my input is 1. If input is 1, the sequence, the possible sequences are, one sequence is 0, 1 and 0, and then another one. Okay. So this could be the sequence. I could have reached S3 because of this path, S0, S1, S2 and S3. The other path could have been S0, S4, S3, that means 1, 0, 1. So by looking at these states, if the input is at S3 the input is 1, then by looking at it appears this would be the next state. So I can say if the input is 1, then the next state is S2, but the output is 0 because we have not completely matched any of the pattern, we are in the midway. So because of that, we say from S3 if the input is 1, the next state is S2. Okay. So this was about S3. So now at S3 also our state machine is complete. Now let's look at S4. At S4 we know what would be the state if the input is 0. Now what would be the state if the input is 1? So at S4, if the input is 0, if input is 1, input is 1, the pattern would be 1 1. Now 1 1 is still the starting of this particular pattern, so the state is going to be S4 again. Okay. If it is 1, then 0. Now S4 is done, S5 is done, S4 is done, S3 is done. Now S5. For S5, if input is 1, we know it is going to be S2, but what would be the next state if the input is 0? So for S5, let's talk about S5. Sorry, can we sub this also? So at S5 input is 0. Now if input is 0, that means that what was my S5? S5 was 1 0 0, and there is another 0. So this another 0 means that none of the pattern has matched. It could be only the starting match, first bit match of this particular pattern. So the next state has to be S1, which means that 0 and the output is 0. So this way we have completed this particular state machine, and yeah, you are done. Now the next thing could be that because it involves some sort of a judgment at every stage. So even if our one particular judgment is wrong, there is a possibility that whole state machine construction could be wrong. So the best idea at this point of time would be to relook maybe at some particular input sequence. We see that whether we are good, whether we are correct or not. So we'll again fall back to this example, the first example. So let us look at this input sequence, and we see whether we are able to correctly do these state transitions or not, whether we are able to match our output or not, or in what state we are there. So let's try to say when we are we'll try to write that in which state we are there. So when input is 0, this is the initial state machine. So if input is 0, then we are there in the S1 state. S0 state was the before this red line. So if my input is 0, then we'll go in S1 state, and now input is 1. The next input is 1. Because next input is 1, we'll go to S2 state. Good. And after that, next state is again 1. So the next state is 1, so we are there in S4 state. After S4 state, the input is 0. Because input is 0, so we will go to S3 state. And after S3 state, the input is 1. So from S3 my input is 1, so we are there in S2 state. And then the input is 0. So from S2 state my input is 0, so we are there in the S3 state, which is correct. So the output is 1. Okay. Now from the S3 state we have received another 0. So from there we have received S3, we have received another 0. So we are there in the S5 state. From S5 state we have received 1. From S5 state we have received 1. So we are back in the S2 state. And we have done, because from S5 to S2 we are receiving, so there is 1 as output, which looks good. And from S2 state we have received further 0. So from S2 we have received further 0, so that means we are in the S3 state. And there is a 1 output from S2 to S3. If the input is 0, then output is 1. So this one is also correct. And then from 0 we have 1 output, 1 input. From S3 the input is 1. That means we are back in the S2 state. And after that there is another 1. So from S2 we have received another 1. We are there in the S4 state. The output is 0. From S4 state the next input is 0. That means we are in the S3 state. So this way we are able to foolproof, and we are able to check whether our state machine is correct or not. This is kind of a recorrection or rechecking method that we should perform. Now by looking at this example, which was at least more complex than the example which we have taken in last lecture, now we can also summarize that what are the steps if we come across any particular sequence, any particular example. What should be the steps which we should follow, which we should follow whenever we are constructing these state machines. So let's summarize that what would be the steps. So first step I would say is so the first step is take an example. Take an example sequence like this. So if we have taken an example sequence, then it would always help us. It is helping us in two ways. One, it is we are now clearer in our mind that how should my output look like. The second thing is that whenever we need to look at any particular sequence, we can look at this particular example and we can see that what should be our next state. The third thing is that when your state machine construction is finished, then also you can use the same example to verify whether everything was correct or not. So this is one. The second thing is that we can start with one sequence. So if there are multiple sequence, in case of multiple sequence, start with one. Any one, it doesn't matter which one. So if you start with any one of the sequence, then we can build on. Okay. The third thing is it's good to create such kind of a table. So this table is very helpful. So if you use this particular table, try to have some semantic meaning of each state. Yeah. So if we try to have semantic meaning, so the semantic meaning also, there is also one corollary here, that first of all you have to try to find out the semantic meaning. Also by looking at the sequence, we should also see that what should we remember. So what should we remember? If we need to remember all the bits, what bits are important to be remembered? Here, for example, we have seen that 0 1 0 was not important, but 1 0 was the only information which was important. Okay, so what information is important to be remembered? That is what is maybe the semantic meaning of the each semantic meaning of each state. So once it is done, then the fourth step along with the direction is will whenever we are taking starting with one sequence and we'll take it to the conclusion, we'll say that till that output is 1, then we can start with the second sequence. So one of the next step would be then complete the state machine. Complete the state machine means that for every state, for every input, we should know that what would be the next state transition. Correct? So and the last step is once the state machine is complete, we should verify. So if we are following all these 4-5 steps, then there shouldn't be any problem. We should be able to create finite state machines. Now there is one question which arises in our mind, that what would happen if the states we are creating could be redundant or could be more than what is expected. Yes, so this is an important problem which we'll try to address in one of the next lectures. So there is a good possibility that we may be redundant in adding these states. We think that okay, this information is important, this is required, but that information may not be required as such. So there must be a method so that we are able to remove those redundant state. We are able to so we are able to reduce the state machines if the number of states are more than the desirable states. Okay, so with yes, so with this particular topic is finished, and now we understand that how to create finite state machines given a more complex problem.